Hello everyone, this is Ethan Whitman presenting the maze problem in BFS, and this is also in C++. So first of all, what is the maze problem? The maze problem starts off with a mouse or a rat who has to walk the labyrinth from the entrance, which is the top left, to the exit, which is the bottom right. The mouse can't walk through ones, but can go through zeros. You have to find the length of the shortest path and how many shortest paths. And you have to input n in the labyrinth. And this is just an example that we'll go over later, where n is equal to 4, and this is a matrix. So then you have to do the maze problem in BFS. So these are the steps. So step 1, push the start point in the queue and start the while loop. Then you have to check if the rat is at the finish. Go in one direction, get the x and y from the direction. Check if it is available. And if it is available, you continue step 5. Otherwise, you go directly to step 6. Step 5 is push x and y into the queue. Step 6 is to repeat steps 3 and 5 for all 4 directions. And then step 7, you have to repeat steps 2 to 6 until queue is empty, which then the while loop stops. So here's just a visual example of the example that I showed you previously, where white is the zeros, which the rat can't or the mouse can go through, and the one is the red, and blue means visited. And I have a visual queue down here, so then you can see what's the queue, and then the distance and the ways, which will update. So the first one, 1, and then it keeps on updating. So 2 is this way, then 2 is down here, which these are the distance, and I'm just keeping track for you, so then you'll know what's the distance. And the queue keeps on updating, so now it's 0, 1 from this spot. So 3, 3, 4, 4, 5, 5, 6, 6. So 7. So now it came from this spot, 2, 3 to 7, 3, 3, which the distance is 7. The ways is 1. Now you come from 3, 2 to 3, 3, which then you have to add 1 to ways since the distance is also 7. So then 3, 3, there's no connections, and 3, 3, there's no correct connections. So then the final result is the distance is 7, the ways is 2. So now I'm going to go through my code that I did for this problem. So I included IOstream vector and queue. That's my usual amount that I include, and that's the necessary. So then I had the vectors maze, visited, distance, and ways. And then I had the directions arrays. And then I have the inbounds function, which that just checks if it's inbounds, and int, it could also be boolean, both work. And then I have the parameters x and y, and I check if they're in the boundaries first. And then I check if it's a valid spot in the maze. And if any of those are not true, then I just return false, or else I just return true. And then I made a struct that contains the x and y, so then I can store them in queues or vectors. Okay, so then I have BFS function. So I just made a queue. I pushed the start point into the queue. I said visited, ways, and distance. The start point is equal to 1. And then I have a while loop that checks until the queue is empty. Like, remember the steps that I talked about? So yeah, this is basically it. So then I get the x and y from the front of the queue, and then I check if it's at the end. If it is at the end, then I don't need to check in 4 directions. So then after that, I go in the 4 directions using a for loop, and then I get my new x and new y. I check if it's inbounds, and if it is inbounds, I check if it's visited. If it is visited, then I check if the distance at new x and new y is equal to previous distance plus 1. If it is, then I add the ways x, y to the ways nx, ny. And then if it's not visited, I just update visited, distance, ways, and I push the new location to the queue. And then in the main function, I just get the inputs, set up my vectors, call the BFS function, and then I just print everything out. So yeah, thank you for watching this video, and please click that like button to support me, and see you later. Bye.